Test, test. Can you hear me?
I can hear you. Oh, you're right here.
Can you hear me now?
I didn't know you were right behind me. I'm like, I can hear you. I was like, I thought you were...
Hello everybody, I'm excited to see you in Chicago, and I want to talk today about the new Argen Z GT. Give you a little sneak peek of the product that's coming out right now, currently in beta. The Argen Z GT marries the best of both worlds with a 4Y and a 5Y zirconia. So the Argen Z GT has 1250 megapascals in the gingival area, 1250 megapascals in the middle where your bridge connectors are, and over 1000 MPa in the transition layers as we get in the incisal. The incisal is 850 megapascals, giving you a 50% translucency in the areas where you need it. So you get the strength where you need it and the aesthetics where you need it. With the Argen Z GT, we have a patented smart gradient technology, which gives you micro mamelon effects in each layer, which reflects light more like natural teeth.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line Ori 3.0 intraoral scanning system without buying any inventory. Ori offers lab owners $0 down monthly pricing and a fully turnkey scanner program. Ori ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
What exactly is smart gradient technology? Stay tuned as we discover the answer together. Let us begin with a common multi-shade disc. I've seen them. You've seen them. Indeed, they are everywhere. But how are the layers arranged inside? Let us open one up and see for ourselves. Here we see where a future dental unit will be placed. But we still require those multiple layers. Let us add them now. There we go. That is quite professional. But wait, aren't those lines a bit harsh? Let us look closer. Oh dear, they are very harsh indeed. We simply cannot have that. But does this affect the final product? Behold, this is a photograph of a competitor's disc. Oh my, look right here. And here. That is certainly not the Argen standard. There must be a better way. Wait, doesn't Argen have a superior plan? How can Argen possibly improve upon this? Let us observe what Argen does to these layers. Well, look at that. They have blended them to more closely mimic nature herself. Isn't that something? Now, when sintered, we achieve a marvelous natural blending of these layers. Fantastic. This structure exists within the tooth, not merely as a surface variation. The result? A natural-looking translucency, just like, well, nature. Argen ZGT is precisely what you require. It possesses marvelous strength and truly smart gradients. Let us take a final look at these layers to see what makes them so intelligent. Observe, Argen has placed the layers exactly where they are needed most. We find great translucency at the very tippy top of the teeth. Yet, just below, the material grows stronger where the connectors reside. At last, we can have everything we need. The versatility of ZGT. That is very helpful in keeping things strong indeed. But you may wonder, is this disc suitable for every indication? Let us investigate. First, let us look at a simple crown. The properties of Argen ZGT make it ideal for those aesthetic cases traditionally reserved for Argen ZSTML, 5Y zirconia, or even lithium disilicate. Now, you can simply utilize Argen ZGT and be confident that your crowns will be simply beautiful. Now, what about those tricky bridges? Bridge cases benefit from aesthetic beauty and translucency in the incisal gradient without sacrificing strength in the connectors. Argen has you covered. And what of the full arch? These too benefit from that same beauty and translucency, while the transition zone is strategically placed to allow for even the largest of arches. So, for crowns, bridges, and full arches, Argen has precisely the disc for you. And tell me, why carry such a cumbersome variety of discs in different strengths and thicknesses? Simplify your laboratory and carry only Argen ZGT. It truly is the disc you've been looking for. Argen Z, better than your mother could make. That is, unless your mother works for Argen.
everybody. I'm excited to see you in Chicago, and I want to talk today about the new Argen Z GT. Give you a little sneak peek of the product that's coming out right now, currently in beta. The Argen Z GT marries the best of both worlds with a 4Y and a 5Y zirconia. So the Argen Z GT has 1250 megapascals in the gingival area, 1250 megapascals in the middle where your bridge connectors are, and over 1000 MPa in the transition layers as we get in the incisal. The incisal is 850 megapascals, giving you a 50% translucency in the areas where you need it. So you get the strength where you need it and the aesthetics where you need it. With the Argen Z GT, we have a patented smart gradient technology, which gives you micro mamelon effects in each layer, which reflects light more like natural teeth.
John Wilson here, about ready to go on 10 minutes before the live stream here, speaking for Argen, digital ROI, where predictability beats pride.
Okay, good morning. I think I jumped the gun there. Before we get started and I introduce our speaker, I do want to let you know this program is being live streamed. And so for those of you joining us online, please make sure that you go into the YouTube channel and that you register on Eventbrite so you can get your CE for this course. And also please like and share this with anybody else who'd like to get information. So as we get started, I have the honor once again, to introduce a great friend and a great partner to Argen, Mr. John Wilson. And my guess is if I were a betting woman, most of you in the room already know John. But for those of you who may not, John is the owner and a master dental technician of Sunrise Dental Lab in Southern California. And John's focus really is full arch implant dentistry and advanced digital workflows. And so you probably see John often sharing his knowledge very openly and willingly, and we just can't be happy enough to have you join us here again with a new topic and slightly unusual for John because he's much more technical than what he'll be talking about today. But the information is going to be fantastic, and we're looking forward to it. So thank you.
Well, thank you guys. First off, you guys got up early. And it's Saturday. And the most amazing thing about the people that are in this room today is you chose to come and listen to talk about numbers. I'm not known to be a numbers guy. I'm one of those guys that really love the technology aspect of what we do. I think if we're keen to really think about how we stay relevant in business, well, we got to retain the revenue, right? You just don't have to make it. You have to be able to keep it. So today we're going to talk a little bit about some strategies. I think that the first thing that I have to start with is this is an uncomfortable subject for me because I may be in a little bit different category. And this is not to brag, but I just have always had that mantra that you just charge more and the leaks won't be so bad. But the truth is, guys, you have to really have a way to measure. If you're not measuring, you're certainly going to find out that you're going to have many more leaks than you ever thought that you had. So this sexy guy right here is obviously me. We have to have this obligatory slide where we talk about ourselves, and it's probably the worst part of my day because I'm just a technician. But there's things that have framed me in this life, and I'm proud of them. I've been making teeth for 43 years now. I'm framed by that analog wisdom and the fundamentals that I somewhat see as a commodity that's starting to fail today. I think that the relevance to what we're doing is dictated by our past, and we have to look and be honorable to the things that got us to this position. I think the reason I'm still doing dentistry today is I have maybe a character flaw of being too curious. I love to figure things out. I love to look at opportunities and think about ways that I could do something maybe slightly different than what the norm is. So today, as we go through this, I'm going to share some struggles that I've had in my lab. I don't think I'm unique. There's going to be some questions that I'll have for you along the way. And the interaction is really where the learning actually comes. Today, I like to say that this little lecture is maybe about relief. Thinking in a different manner, trying to come up with ways that are going to meaningful make something change in your business. Less stress. Man, how much stress do we already have in this world? If you don't know your costs, well, you're going to have a lot more stress at the end of the month when you start looking at the bottom line. So we have so much struggles that we're doing in this stuff, and to try to be this accountant is really, really difficult. This is what I want. I want to find predictability in every aspect of the trade. I look for this aspect of my life. And it takes measuring. It takes the strength to look in the uncomfortable places. But I'm going to start off with this slide. I'm definitely not an accountant. Anything I do say here is my opinion. Don't take it as verbatim, but what I will say is this little lecture that I had to put together made me look deeper at my own business. I didn't have the words to be able to say what I already felt. And maybe many of you are in that same position when it comes to manufacturing. Back in the day when the machines were our humans that were our technicians that were sitting there, we could quantifiable labor pretty easily. And if they had a bad day, well, we could figure that out. Now we have, multi-million dollars of tools in our laboratories doing things that they could do better if we tell them what to do, right? So, the thing that I found in my life is so often that want is somewhat overpowered by real need. And when I say that, it's because we've based a lot of our decision-making on emotion. If you could separate emotion and many different aspects of our purchasing power and to be able to be honest with ourselves about our ability to run certain tools, well, we can make better decisions. This is your first math lesson today. It's not a good lesson, but it's an honest lesson, and if you look at it, there's one metric here that I want you, in your own mind's eye, think about what it really means. How would you define true cost in your own mind? Just keep it silent, keep it for yourself. And maybe I'm going to share a little bit different idea associated with it. I think that true cost is not materials. How many of you guys thought true cost was material? Cheaters. The truth is, it's disruption. The frustration of all the things that account in our day-to-day, how it affects our actual workflows, what we're actually paying to overcome that event. And the hardest part when we look at this aspect is, we have to really just jump around and change our schedule, bring our senior techs to different levels, push off other work just to play catch up. That disruption has a metric, and that metric is very rarely measured. We're not putting a number assigned to it. So, if we're keen to look at this equation again and enter in this aspect of it, let's think about two things. One, your volume doesn't cause this, right, guys? It's just going to amplify your understanding of where your leaks actually are. I'm going to share a couple little business models that I've used in my laboratory to try to track. And I'm going to talk specifically about harder geometries. I think all of us by now have figured out what it kind of costs to mill zirconia. And there's ways to maybe tweak it a little bit more, but it's the big, more complex geometries that really become a challenge. And so often we want to get excited about, oh, I'm going to buy this metal mill, I'm going to bring it in, I'm going to be the next Pantera. And the cost associated with this procedure is daunting, and the profit is low. So you have to look at this and look at this model. So we're going to talk about, say you are a lab doing 5 bars a week. 250 bars a year, it sounds like a lot, but for a smaller laboratory, that's a substantial thing. But somehow, some way, you've scaled to 500 bars. Well, that waste that you've already know that you have is scaling way faster than the profit margin. So now you're making less per every bar that you're doing. So what do? I'm going to run through this model real quick, and the truth is I think most small labs are so busy becoming the artist and producing the beauty of what we do that we lose track of what really matters. The data. The data tracking our successes are great. Everybody wants to feel great at the end of the month when the revenue is up. But the most important metrics are the struggles that you have in tracking the remakes in a manner. How many of you have a real precise way to know how many things have failed in your laboratory other than the fact that you just push remake? I know that I wasn't the greatest with that over my career. There's 3 categories of remake. It's the one that you are frustrated with. It's the one that you don't want to talk about. And it's the one that you definitely have to call the doctor on. The third category is the worst. An internal remake is the most costly thing for your laboratory. It costs you your reputation. And this is what I need to talk to you about today. How do you measure that aspect of it? So we're going to talk about this business model again. So 5 bars a week, $250 a year. Your fixed burden after your capitalized cost, and let's just say a round number of 60 grand. Well, your variance for that variable is $390. That's before you put your fixed costs in there. So you're going to have a total internal cost for your bar of, say, $630 in your first year that you're milling. And I use the first year model because you are going to improve. You're going to get better. But if you calculate what it costs you to send it to, say, a good milling center like Argen, and you produce something that is maybe $800, you have a fixed cost for $800. Well, your delta before that disruption is only $170 for that bar. After all the headaches, all the work, all the stuff that you've done on this, what are you actually saving here? And how do you quantify that disruption? So if we're keen to understand that concept, you have these same rates, but at different volumes. What's going to happen? You still have the same leak. You haven't fixed a damn thing. You're struggling with the understanding of what your real costs are because you're not measuring. So we're looking at these percentage and dollar values now. Same business model, same leak, same everything. Look how everything scales higher. Every single aspect of your production is a leak. And we're talking about one specific product in your laboratory that is difficult. The hard part for us to really is to really own the fact that maybe we don't have a solid fundamental understanding of what our true costs are to produce a product. You know, we're pricing our product based on what the industry says they're willing to pay for it often. And if you decide to really break it down and look at it, well, there's a thing between scrap and what I call remake. Your scrap, obviously, is all the materials that never leave the lab. You know, how many times have you gone through and burned through a disc and screwed something up and wasted all the mill time and you didn't even know until the very end and you have this? It's wasted money. How are you tracking that? You're just throwing another disc in and checking the simulation and remilling. You're not tracking that number. So we have to have some averages here for this conversation. We're just going to say we have 6% scrap on this business model. That's another $16,500 that you're just throwing away. Now those even more devastating things, the remakes, the stuff that goes outside. Industry, if you can be below 3%, hallelujah. The reality of these bigger cases, they hurt a lot more because there's more to them. There's more responsibility. There's more challenging aspects of what your clients are going to respect out of you when things fail. So the business model then goes back to that disruption as well, because now you're putting all your effort into something that is making smaller margins, but have a bigger potential problem for you. In my lab, you know, I've said this for years, that it's those quiet little drips to the bucket that finally overflow, and you get to the point where you don't really even see them if you are not consciously looking for those leaks. It rarely feels like horrible, overwhelming burden. It always will feel like a little bit of pressure because you know something's there, but you just don't know how to measure it. It's the measurement that you allows yourself to control your costs better. You know, everybody says digital dentistry is so ridiculously expensive. I can't adapt. I can't move to this because I have this burden of buying equipment and utilizing it on a daily basis and learning how to do it. Where the real value is you're disciplined to understand how to use it correctly. So I like to say undisciplined digital dentistry is exceptionally expensive. And I'm trying not to run through this topic too fast, but I think this is a real powerful statement. You know, we all have tuition in our lives as it relates to the business, as it relates to relationships. We have to learn how to do things better. We don't just consciously walk into a room and have it all figured out. And that's another metric that is never on a line item anywhere. I call it the tuition year. Every lab goes through the burden of learning how to do this stuff. The only real question is when and if they will ever graduate from that lesson. Again, value. Having value in what we're doing. I'm going to tell you a story. I think that I'm not unique to this world. I I have a set of goals every day to get up to, honor the time that I'm given, to be able to make meaningful change and to look for opportunities to improve not just the people around me, the clients that choose to partner with me, but myself included. So for the longest part of my career, Friday was the day that I worked the hardest. Because for me, on Friday, if I half-assed anything, I was paying double on it on Monday. After the weekend, when I'm coming in on Monday morning, I want to be jazzed about coming to work. So this story takes me back. I thought I had my milling strategies just perfect. We were down to the wire on a case. It was going to go out on Monday. I needed to get this bar in the mill. It's end of the day. I'm stacking it up. I'm going to push play and go home. And I'm futzing around and real difficult strategy. And if you've never heard the sound of a big rough-end burr just snap on a disc, it will just shock you. So the titanium bar had a 3mm rougher, and I had to get this case rolling. And I snap a burr. And now I'm wondering, do I have a backup burr for this? How am I going to do this? What is this going to actually cost me? How is this disruption actually going to metric out? There's nothing worse than looking at this and thinking that you have graduated some sort of form of competence and you have this failure. It might just sound like a simple story about a burr breaking and a thing, but it's deeper than that, guys. It kept me to start thinking, well, I did everything correct. I looked at the simulation closely. I looked at every aspect of what I've already learned to do, and I still failed. So tuition, it's not the machine's problem. It's maybe your problem. It's a discipline problem. And the discipline is that you get comfortable at times and thinking that you're doing the best that you possibly can, but there are signs. So here's your next equation for the day. So that delta cost in the middle times the volume equals your tuition. How would you ever put a number together except for, hey, I went to this course, I paid this tuition to get some knowledge? Well, how do you equate that to your business? How do you equate that to your evolution in machining? I can guarantee you this, I never wanted to be a machinist to start out with, but I pushed myself, and much like this lecture, I had to step outside my comfort zone and look for solutions. So the delta cost in this equation is the difference between your first year cost to produce a unit versus what I call your mature cost. Your mature cost is when you kind of figure things out. And the real variable in this equation is when are you going to figure it out? It takes time. Putting in the reps on anything difficult is going to have failure. Tracking that failure, understanding the real metrics associated with it is going to give you a value. So the value is this, guys. Let's just use this round number again. You got $600 it's going to cost you to make a bar in the first year. After learning how to not snap every tool on every bar and learning how to yield a little bit more material out, and you drop to, say, $450 to produce a bar in the next year, well, your delta on that year was $150 per bar. That measurement is something that very few people do. But that's 60 G's right there in this business model, and it's so powerful to understand that if you have a way to track your achievements, you could then put your focus to the things that are going to be best set for your specific business model. I like to say that the harder you look at the numbers, the more you can learn from them. But it takes discipline to look at those numbers in an objective way. End of the day, when we're trying to total things up, we come up with this equation in our own minds that the good's going to take care of the bad. But I like to say that maybe when your graduation comes is when these 4 things happen. Tuition never really ends in my life. I am continually looking to improve, but the measurable aspects seem to get smaller the more reps you put in. But these are the true things. If you can say to yourself that if I have this, then maybe you've gotten to a point where you actually understand a little bit about machining. So this discipline layer that I've been yammering on about here is based on predictability. That predictability is not just given to you. You walk into the laboratory in the morning, you're not going to push play on a machine that you just got and have success. You have to put in the work, guys. And I can tell you, for me, started looking at the little things. Little things to me add up big. You know, we're looking at tool pricing and in a manufacturing aspect, and we're looking at the cost of what we're doing. In the very beginning, we were looking at tools and seeing such a wide range of pricing. Again, I'm going to take a simplistic route here and look at just one tool. Let's just say a 3mm titanium rough-in burr. You could source that burr from anywhere from $25 to $300. Is the $300 burr that much better than the $25 burr? Well, it's not going to be something that you're going to figure out from the actual literature from the manufacturer on it. It's something that you're going to have to experiment with. So what do? We buy into a system. We buy their tools. We start utilizing their tools. We start learning on those tools. But the costs associated with this can be dramatically changed once you learn what your base numbers are. So that tool life is the lever. It's what you get out of the tool. It's not how much you pay for it. It's a metric between the two. And we're going to look at small numbers, but small numbers add up to big things over a yearly basis. If you're buying a tool for $30 cheaper, but it's yielding so many fewer parts, well, it's costing you more per part to produce. And then this metric, we're looking at just one rough-in burr that is going to save you, what, $2,000 or so a year on this one tool. Well, in my lab and in my specialized stuff that I do, I have over 30 tools for just metal. So think about the loss on there by not recognizing what tool is a better value for you. That experience and you putting in the reps to actually try things and to track it. How do you track? I can remember when I first started with machining and doing zirconia. I'll tell you a story. Salesman comes into my lab. John, you have to have this milling machine. It's the best thing ever. We're going to set you up. We got you this great package. We're going to do it. And the first question I asked the guy, I said, well, what's it really cost me to mill a crown? And of course, they don't have the numbers. Back in the early days on this, they were saying the division of how many units you can get out of a disc, and that was it. But I knew the tooling was going to be the determinant. I knew that the amount of remakes that we would have internally from the crown never getting out of the disc. So in this time when I'm looking at the metrics associated with tooling, I decided that I had to start tracking. And it was simple. I had a piece of paper on the side of the mill and everything I would crosshatch. Sounds silly, but that's what I would do, and I would be keeping track of some real-world numbers. That's the only way I could do it. I then correlated it to the mill's mill time, how long that strategy took with that tool, and then calculated its true tool life. And having a good understanding of what that tool, how long it can live, then gave me the opportunity to source tools that were cheaper that had similar characteristics. But if I wasn't keen enough to look at the real measurement of how long that tool was going to last, and I just went for the base number, I would be solely wrong with if it's saving me money or not. So this next set of concepts, I think when you buy a $100,000 mill or anything to it, there is a starting point. How many of you have ever in your life said, if I just bought this mill, then I could grow? If I just had this new printer, I could be that much more efficient. If I just had this, just had that, I need that. And you hadn't even structured the amount of volume of work that's going to necessarily need to be able to fill that mill to make it profitable. I like to say that spindle time or spindle optimization is something that I don't think many people talk about. You have this expensive machine in your laboratory. How are you using it effectively? How many hours in a day is it running? How many wasted hours in its life is just sitting there costing you money? Technology is expanding and changing, and we have to make return on investment on our machines as quickly as possible. So having real-world understanding of what your throughput in your laboratory is will allow you to calculate costs. So if you have this mill and you throw a lifespan of just 8 hours a day. Let's just say you're going to run it 8 hours a day, 5 days a week, 50 weeks a year. It's 2,000 available hours that you have to make something on that mill. Now your metrics have already been counted for when it comes to other products. You know what you can make with that mill milling zirconia. But now it's got this multifunction. I can mill bars in it too. So I'm going to start milling bars in this, and you're wasting the time. You're not utilizing it effectively. When we look at these numbers associated in the middle of that graph, the cost associated with what we think as a fair and adequate use of a machine is that middle ground there. Anything below that level, you're wasting what you've already paid for. Whether you're amortizing it or you've paid cash for that machine, you are wasting potential. If we look at it keenly and we look, well, why would we want to have that at 100%? You see where it says it's risky? Well, you can't maintenance it correctly. You have opportunity for the machine to go down. If you don't have redundancy and this is your only thing, well, you're dead in the water if you kill it. So you have to put realistic numbers on what it can do. And once it gets to a certain level, that sweet spot of 70 to 80% there, you start looking for opportunity to increase your throughput by adding additional machines and having redundancy. So that idle spindle time, it's costing you money. It's prepaid waste. It's things that aren't going to show up on your balance sheet. But I can tell you this much, if you are keen to look at these little things, it adds up and makes a difference. That 10%, just 10%, that's 200 hours that you're wasting in a year that you haven't put a part in there on this very minor amount of work that you think that you're making in there. 200 hours is substantial. Making something of value, something that's based on your own business's metric for this. That's real leverage lost on this. You haven't utilized that piece of technology in its best form. I think so often when we're talking about material and reductive technology, it's difficult, guys. And again, I'm still talking bars here for these numbers, but the truth is when you look at how wasteful reductive technology is already, when we're looking to increase our yield, to be able to get more out of this expensive material rather than just have it go in the scrap can. How many discs in your lab, when you walk in there and you look at it, and it could even be just zirconia, and you have one little spot left in that disc, and you feel like you can't throw that away because you know you can get a single crown in there sometime. That's great. We all have done that. And ultimately, by the time we remember that you have that disc over there and you get to it and you then next it and then it fails. It's just waste. We have all of these discs in our lab sitting around there. And when I look back at my early metal milling discs, well, I was afraid. I was afraid of breaking things. So of course I was making all the wrong moves. I was increasing the offset, widening things up, giving myself more room for that tool to move around that pattern to avoid the potential for collision. That tuition has taught me that I can run this cleaner if I understand what the mill actually needs. It's the hardest part of this equation is we've been given the tool to be able to point and click and somehow produce a product because our manufacturers have turned us into machinists overnight without any real training. So the hardest thing to really talk about is, do you want to get better at what you want to do, or do you want to rely on somebody else to tell you how to do it? So for me, my yield and my increase on what we're doing was all based on how I could make the offset smaller so I could fit more patterns in a disc. That took time. It took dedication for me to understand that if I design this way, I'm going to struggle to be able to machine it without waste. So you can look rather clearly, this is just one more product here. If going from 2 to 3 is about the average of most labs can do. If you can get 3 bars out of a disc and the average size for a full arch, you've done something really good in nesting. Can you get to 4? Yeah. But I can tell you right now that it has to be, specific sizes to make it work. But if you're thinking about that, if you have the throughput already, if you're already planning for your week by what you're producing, well, you can yield more out of that disc. And ultimately, you're not going to have those titanium discs that are sitting there with just one little chunk left that is never going to fit anything else in there. It's a lot of waste. So this is one of those slides that just says numbers, 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 and you're spinning your head, and you might look at it later and wonder what the hell he's saying. So I'm going to make it real easy. The left side is what you want. That's ideal. The right side is not so great. Where you fall in the middle here is probably where most labs operate today. And what does that really tell you? Well, it tells you need to know what these numbers are. You need to know how you get to these numbers. This is the most powerful statement in the slide to hear. If you're not measuring, guys, you are going to make the same mistakes or worse. You're going to continue to make trouble for yourself by not really recognizing it. You have to not just look at one part of the equation. It's a system of multiple different disciplines to look at. I think that alignment across all metrics is where you really save and when you can really say that you have actually learned from your mistakes. I think so often when we're looking at what we do on a daily basis, we feel, prideful for the things that go well. I've really twisted my life to really look at the things that just fall apart. I think I've learned more from the days where I'm just struggling to get a pattern off the mill. I learn more from the times where I think that I'm profitable and then I total things up and I'm wrong. Because that's where the growth happens. If you're not pushing yourself to learn and experience new things, I think that the discipline will never come. So having alignment across all metrics is paramount for your growth. Here's the biggest part of what every lab on this planet is doing. Those strong departments, you have a Crown and Bridge department, that's your gravy, that's where the money's coming through. That's what has very tight metrics associated with it because you know what things cost to produce there. You have that thing nailed down just perfectly. And it allows you to cover the leaks that you have in the departments and the materials that maybe you're not so great at. And I use the metal part of it because it's a growing part of our industry. People are wanting to learn more about this, what it really costs to be able to do this thing. And the old statement that the good's going to take care of the bad in your laboratory is a really dangerous statement. Because the revenue, the bottom line number that you're looking at, what you produce that month, can really hide so much inefficiency. And I don't want to just stand up here and throw buzzwords at you, but for me, guys, This term, I'd never heard of it before, margin masking. I knew what it was in my heart based on the old saying, the good's going to take care of the bad, but this margin masking isn't safe. It just makes you feel good a little bit because you see that the revenue is growing, but if you really don't know how to track your true costs, you're not getting better at anything. So here's something in life, I think that we all want to feel that we can be great at everything. There comes a time when you have to put your effort into the things that are going to move the needle most for you. I think it's real growth when you can recognize that that strategic restraint is actually real leadership. Meaning when you can tell yourself that, hey, maybe I'm not so great at this, and either choose to find a way to get better at it, or you look for what? You don't need to do everything in your laboratories, guys. We're in an amazing time in our lives where we have strategic partners. These partners in your life can really add value. But more importantly, as you grow your whatever department, you have options to be able to have predictable profit margins with outsourcing. Now, this isn't just an advertisement for Argen, but I have an opportunity to share my path with you. I stand on this stage as a true partner to Argen, not because they asked me to come and speak for them, but because I use their services. You may see me on social media doing all these big, crazy cases, and that's only part of who I am. We have many different things that I don't keep in lab. You know, we never cast anymore. Everything goes to Argen. We never mill anything that's not really going to make me good money. All of my frameworks are going to Argen because they're predictable. We used to cast all of our frames in-house. I don't do that any longer. All of my gold crowns are milled at Argen. I buy their zirconia. I have a strategic alliance with this company, but it's not just because I like them. It's because I've recognized where my strengths are and where I can expense things to make margin. The things I do infrequently in my laboratory that I choose the hard stuff to do personally, I know today I am not making the most that I could on that because I haven't put in the reps to know all of the things. As many cases I've done, I'm still not to the place where I have a measurable metric to really know. But it's fun, and I love it, and I enjoy pushing these mills to do things that manufacturers never intended them to do. Now we get to the part of this lecture that is my story. You know, you may have seen me as some sort of expert with Sega printers. They did a story on me and Min at my little laboratory. I can tell you right now, I am not a printing-loving guy. If you love printing, hallelujah. I think that you found something that's great, wonderful. Printing to me is a nightmare. It's hard, it's a struggle, but it's necessary. When I first started in this industry, you know, obviously digital was the future thought. We were still doing 85% analog gypsum models for the longest time. But I looked at the numbers. I started outsourcing. That first 15% of our digital files that were coming in, I wasn't going to buy a printer for 15%. That was just going to distract my plaster guy from the things that was really mattering for us in those times. But I was key to understand that as things scale, it may become more profitable for me. So this is where the real magic was for me because I chose many different outsourcing centers to send models to. And back in the early years when we were getting models back, we would get some models that were great. And then we get these models that were, what were they thinking? How did this get out the door? Why did this come this way? And I started thinking to myself, if this multi-million-dollar company can produce models on a level that is inconsistent, How difficult is it going to be for me? Why am I going to have that success that much faster on it? Why is it difficult for us to do this? And I never could figure that aspect out, but I eventually got to that frustration point, because if I don't try to overcome those problems, well, then I'm the problem itself. So I jump into my first year of printing models. And when I look back on this and I look at this slide, it crushes my soul, because it is a true testament of my inability to understand true costs in additive manufacturing. The break-even point on this was after several thousand models to get even close to the line that this manufacturer had already been outsourcing the numbers to me. I was ineffectively using that first Pro 4K. I was buying the most expensive, ridiculous resin that was on the planet. I was printing all models solid, because in our business, our diagnostics were always beautiful. Beautiful white study models, ortho cut, just gorgeous when they went out. When we had wax-ups on there sent as diagnostics back in the day, this was our calling. They would hold it in their hand. They'd feel that weight. It was just a testament to the craftsmanship of what we put our pride into. So transitioning to printed models, I needed to have that similar thing. And these models were exceptionally expensive that first year for us. One, we didn't know what we were doing. Two, we had a tremendous amount of scrap. And it pushed me to look for options, pushed me to really think differently about this stuff. And there was a reason why I stuck with Argen, printing most of my models for the first 6 years of digital dentistry for myself. They were a great partner to me. It took one thing off my plate. It allowed me to save one technician from joining the crew again. So once we got to about, today we're at 90% digital. We still have a small amount of gypsum models being done. We've transitioned our staff to train them to do new things. We have 4 big printers in my little operation, and we have our prices in check. This slide is really telling you, look at the cost and how it's going down and down and down, and then you'll see it stair-step up. And we found in those stair-stepped areas, we were forced to either buy another printer or bring in more help to be able to produce the throughput. And these numbers here are a telling testament to just one product. How you make your printers make money for you is by adding additional items, right? I'm stuck making these, what I call restoration holders. It's something that's going straight in the garbage, but it has value. It shows that your pride to this. You know, if you're not taking the time on your model work, I know when I started up in the gypsum room, it was the foundation. It gave everything to us. So when I transferred into a digital realm, I couldn't make a lesser product, which required, obviously, more attention to detail, more cost associated, more labor associated with the design elements of it, to have the pride to be able to give this the John Wilson seal of approval. So if we look at these numbers with the additive for me, it initially was what drew me to bring it back in-house was the ability to control the work in progress. You know, we have these time frames that are constantly being pushed for certain items in our laboratory. We have many times crowns waiting in pans for other components to hit the laboratory. There's certain things that I strategically outsource for a reason because it makes me more money, but the work in progress throughput with additive coming into the laboratory allowed us to thrive. It took those numbers, those original outsourcing numbers of $27 for an arch. And I share these numbers freely with you. This is my inefficiency in my laboratory utilizing the most expensive, beautiful white resin that was out on the planet. And my first year cost was $40 a model overall for all the models that I did on average. It's impossible to make money with that. How many of you guys line item your digital models and your restorations? Great. But the norm is not to do that. We're throwing it into the cost of our restorations. And again, those costs are so in flux in many of the things that we're doing today that if we don't really recognize what each little part of the equation costs, well, we're just burning money. So I had to force myself to find a way to reduce the scrap, reduce the volume of resin that I was using, and I got down to $18 without compromising the look of the restoration, the look of the presentation model. That restoration holder is still important to me. But I got it down to a manageable cost that's not going to bleed the cost of that restoration. So that teaching point to me was that while initially it was for flow, I was looking for a way to get the work through the laboratory faster, the teaching moment was that there was metrics to allow me to actually get better at what I do. That tuition was a measurable action in this aspect as well. And it took me from just wanting flow to actually protecting my bottom line. So you have one assignment, guys, here. I want to tell you, I don't want you, sorry, Argen, you don't need to buy anything. Where your path to success is by maybe having just a little epiphany here about costs. You can measure if you're not measuring now. Start slow. Pick a couple little metrics to actually really look closely at. Do it week by week for the first couple months, just to start tracking these things. If you can measure, you will absolutely be more profitable in the end by looking at small things, because the small things fill up that bucket faster than you'll ever expect. There's nothing better than predictability, because that predictability gives you freedom, and it gives you freedom to make other bad choices in your life. Because the bad choices are what makes life worth living in a lot of ways, and I'm full of those bad choices. So guys, I have a couple self-serving slides here. If you want to follow me on Instagram, you can get my contact here, but more importantly, I do personal courses for these three softwares. If you're looking for detailed and complex geometry training, I can help you there as well. I offer this up in a few times a year. I never advertise anywhere else, so it's special for the people that attend these lectures to have that open door to reach out to me if you have any type of need for this type of aspect. Did everybody get that? Was it too quick? Good? This is my passion project. Again, self-serving. But I started a little podcast where I'm just telling stories, and it's all dentally related. It started with a real purpose to be able to share my story with my children. I think that as you get older and you lose your family, they only have a small picture of who you are. And this gave me an opportunity to give this back to my children, but it has grown to the point where I am just shocked on how many people say they connect with the story. So if I have an opportunity to give you a platform to listen to me yammer on a little bit, and you find any connection with it, would be glad to have you listening. All right, guys, that's all I got for you. Thank you so much. I will take any questions that you have, and I'll do my best. Please don't make an accounting.
Any questions?
Hallelujah. It was easy. Uh-oh.
I think it would be a very sobering presentation for doctors looking at in-office everything and all the equipment that they think they want to buy, and their assistant's going to be a dental technician. But so thank you for that. It's very good, insightful. Question on milling stuff too, because burr life, like you said, is a big factor, and anywhere from $25 to $300. Is there a company in particular that you have found that you think they manufacture a better burr life than another?
So you have my Instagram. I will not say it in open forum on that stuff. The truth is I have strategic partnerships for a reason, and there are certain non-dental manufacturers that can produce stuff. You didn't hear that, Stephanie. The truth is, guys, I'm here to be a resource to you guys, but I'm not here to degrade anybody's business model. I want to be transparent in the fact that I'm constantly looking for the next greatest thing. And because I try to measure my failures in a manner, it pushes me outside of our industry in a lot of ways. You know, my growth in these complex cases were all based upon non-dental type stuff. I had to go to read the most dry reading in the world, 5-axis machining forums, to try to understand toolpath and all of the things that were not point and click. And that part, you know, led me down the rabbit hole of, you know, industrial tooling and learning about coatings and learning about which things actually matter and will have lasting effects on the products that we do. And, you know, there's been a part of me for years that wanted to take that knowledge and, you know, roll it into some sort of consulting type of thing. And maybe that will happen if I live long enough. But at this point, I say reach out in there and I'll throw you some links. All right? Anything else, guys? Lachlan. Pardon? I haven't gone down that rabbit hole. That is the next the thing. Let's just say I have not thrown one tool out that has exceeded its life. So I have this amazing collection. I've always wanted to take and make an epoxy table where I make all the tools and pour epoxy into it just to have a really cool thing. It would be probably the most expensive table ever made. But I saw that in my mind's eye one time that would be cool. Lachlan.
Is this working yet?
Yeah.
Are you still doing full diagnostic models, or do you hollow them now?
Yeah, I hollow them out today, and the frustration to it is it just doesn't have the same feel. So I've done it where, you know, the base is solid and it's hollow internal, and I have a couple weep holes so that it's on vertical, so it feels like a solid model. It holds in your hand, and you have 1 or 2 vents off of the end too. The problem is that I've found that when I do that, I have so much more trapped resin in there that even though I have this beautiful feel and I'm trying to save this, if I look at the slicer software versus the real world volume of resin that I've got, it doesn't correlate. So I know there's a lot of dead resin that I can't get out of there. So I know what I'm leaking on. But when you charge enough, and that's the one thing that I didn't really touch on, and I'll be real quick with this, but in my life coming up when I had nothing, my only goal in life was to have enough in the checking account that I wouldn't have to balance the damn checkbook. That was my goal. As it relates to digital dentistry, my goal was to charge enough that those leaks weren't going to hurt me as much because my profit margins was more than most. As I've evolved and learned and all these little processes matter, I start to look closer at those little things. And before on the Asiga software where we would see what the slicer says, how much resin you're going to use, I would calculate, I would do it. I did it for like a month. And then I looked at how much my resin actually usage was and compared it, and it was almost 15% different. So that 15% is going down the drain on paper towels and the resin with fails. So all of those little things, I don't know how many of you guys are that crazy to look at the slicer software and calculate to actually know how much resin each model has and to put a real cost to it. Well, I started doing that and it pissed me off because I couldn't figure out why I couldn't get this number closer to what that software was telling me it was. And then I just recognized it was human error and just sloppiness, getting prints off the build plate and not scraping enough, and just having uncured resin in cavities of stuff that you're just throwing away. But good question.
So, John, we do have a question from the live stream chat. It says, how do you deal with the competition of low-end digital labs bombarding your clients?
So that's a great question. So I'm in a unique position. After all of these years, I've had the fortune to be able to pick and choose the clients that work with me. They come to me. I don't have to chase. And I've gotten to a point where I've made this meaningful choice to keep my footprint, my staff, and everything smaller. So I'm not forced by the pressures of scaling anything today. So I can be a little bit more predictable with this stuff. But yes, I am very keen to it. You know, social media and the amazing digital photos that we see every day with that tiny price underneath it that is becoming the understood norm when clinicians come out of school is scary. It's difficult. It's not fun to be able to see the erosion of our trade based on this aspect. And his comment earlier when he left the room about the in-house doctors bringing everything in-house and how easy it's going to be and how profitable, how much more money they're going to save than sending it to the laboratories, well, again, it eventually will be. And that's the hard truth of it all. The more they put in their tuition, they will save. But that pressure, that power, that frustration of it all to be able to get to that thing is not easy, and not everybody's willing to do that. So you can leverage your own strengths by becoming that expert. Really have the real just vision to be able to talk to your clients as an equal rather than a subordinate. I think that's been my relevance as I've grown and been able to grab a piece of the pie that is a very small piece. You know, you have to think that the types of things that I'm doing is a very niche market and a niche market. So I have to be really good at what I do, and I have to be able to find ways to connect with the people that really want that particular attention to detail. Not every person on this planet doing dentistry today is looking at that. Business of dentistry is an ugly thing at times. You know, you can pick and choose how you can make it pretty. Right? Anything else? Come on, guys, you got to have some fun stuff. All right, thank you very much.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line Ori 3.0 intraoral scanning system without buying any inventory. Ori offers lab owners $0 down monthly pricing and a fully turnkey scanner program. Ori ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
what exactly is smart gradient technology? Stay tuned as we discover the answer together. Let us begin with a common multi-shade disc. I've seen them, you've seen them. Indeed, they are everywhere. But how are the layers arranged inside? Let us open one up and see for ourselves. Here we see where a future dental unit will be placed. But we still require those multiple layers. Let us add them now. There we go. That is quite professional. But wait, aren't those lines a bit harsh? Let us look closer. Oh dear, they are very harsh indeed. We simply cannot have that. But does this affect the final product? Behold, this is a photograph of a competitor's disc. Oh my, look right here and here. That is certainly not the Argen standard. There must be a better way. Wait, doesn't Argen have a superior plan? How can Argen possibly improve upon this? Let us observe what Argen does to these layers. Well, look at that. They have blended them to more closely mimic nature herself. Isn't that something? Now, when sintered, we achieve a marvelous natural blending of these layers. Fantastic. This structure exists within the tooth, not merely as a surface variation. The result? A natural-looking translucency, just like, well, nature. Argen ZGT is precisely what you require. It possesses marvelous strength and truly smart gradients. Let us take a final look at these layers to see what makes them so intelligent. Observe, Argen has placed the layers exactly where they are needed most. We find great translucency at the very tippy top of the teeth. Yet, just below, the material grows stronger where the connectors reside. At last, we can have everything we need. The versatility of ZGT. That is very helpful in keeping things strong indeed. But you may wonder, is this disc suitable for every indication? Let us investigate. First, let us look at a simple crown. The properties of Argen ZGT make it ideal for those aesthetic cases traditionally reserved for Argen ZSTML, 5Y zirconia, or even lithium disilicate. Now, you can simply utilize Argen ZGT and be confident that your crowns will be simply beautiful. Now, what about those tricky bridges? Bridge cases benefit from aesthetic beauty and translucency in the incisal gradient without sacrificing strength in the connectors. Argen has you covered. And what of the full arch? These too benefit from that same beauty and translucency, while the transition zone is strategically placed to allow for even the largest of arches. So, for crowns, bridges, and full arches, Argen has precisely the disc for you. And tell me, why carry such a cumbersome variety of discs in different strengths and thicknesses? Simplify your laboratory and carry only Argen ZGT. It truly is the disc you've been looking for. Argen Z, better than your mother could make. That is, unless your mother works for Argen.
everybody. I'm excited to see you in Chicago, and I want to talk today about the new Argen Z GT. Give you a little sneak peek of the product that's coming out right now, currently in beta. The Argen Z GT marries the best of both worlds with a 4Y and a 5Y zirconia. So the Argen Z GT has 1250 megapascals in the gingival area, 1250 megapascals in the middle where your bridge connectors are, and over 1000 MPa in the transition layers as we get into the incisal. The incisal is 850 megapascals and giving you a 50% translucency in the areas where you need it. So you get the strength where you need it and the aesthetics where you need it. With the Argen Z GT, we have a patented smart gradient technology, which gives you micro mamelon effects in each layer, which reflects light more like natural teeth.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line Ori 3.0 intraoral scanning system without buying any inventory. Ori offers lab owners $0 down monthly pricing and a fully turnkey scanner program. Ori ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
What exactly is smart gradient technology? Stay tuned as we discover the answer together. Let us begin with a common multi-shade disc. I've seen them, you've seen them. Indeed, they are everywhere. But how are the layers arranged inside? Let us open one up and see for ourselves. Here we see where a future dental unit will be placed. But we still require those multiple layers. Let us add them now. There we go. That is quite professional. But wait, aren't those lines a bit harsh? Let us look closer. Oh dear, they are very harsh indeed. We simply cannot have that. But does this affect the final product? Behold, this is a photograph of a competitor's disc. Oh my, look right here and here. That is certainly not the Argen standard. There must be a better way. Wait, doesn't Argen have a superior plan? How can Argen possibly improve upon this? Let us observe what Argen does to these layers. Well, look at that. They have blended them to more closely mimic nature herself. Isn't that something? Now, when sintered, we achieve a marvelous natural blending of these layers. Fantastic. This structure exists within the tooth, not merely as a surface variation. The result? A natural-looking translucency, just like, well, nature. Argen ZGT is precisely what you require. It possesses marvelous strength and truly smart gradients. Let us take a final look at these layers to see what makes them so intelligent. Observe, Argen has placed the layers exactly where they are needed most. We find great translucency at the very tippy top of the teeth. Yet, just below, the material grows stronger where the connectors reside. At last, we can have everything we need. The versatility of ZGT. That is very helpful in keeping things strong indeed. But you may wonder, is this disc suitable for every indication? Let us investigate. First, let us look at a simple crown. The properties of Argen ZGT make it ideal for those aesthetic cases traditionally reserved for Argen ZSTML, 5Y zirconia, or even lithium disilicate. Now, you can simply utilize Argen ZGT and be confident that your crowns will be simply beautiful. Now, what about those tricky bridges? Bridge cases benefit from aesthetic beauty and translucency in the incisal gradient without sacrificing strength in the connectors. Argen has you covered. And what of the full arch? These too benefit from that same beauty and translucency, while the transition zone is strategically placed to allow for even the largest of arches. So, for crowns, bridges, and full arches, Argen has precisely the disc for you. And tell me, why carry such a cumbersome variety of discs in different strengths and thicknesses? Simplify your laboratory and carry only Argen ZGT. It truly is the disc you've been looking for. Argen Z, better than your mother could make. That is, unless your mother works for Argen.
Hello, everybody. I'm excited to see you in Chicago, and I want to talk today about the new Argen Z GT. Give you a little sneak peek of the product that's coming out right now, currently in beta. The Argen Z GT marries the best of both worlds with a 4Y and a 5Y zirconia. So the Argen Z GT has 1250 megapascals in the gingival area, 1250 megapascals in the middle where your bridge connectors are, and over 1000 MPa in the transition layers as we get in the incisal. The incisal is 850 megapascals and giving you a 50% translucency in the areas where you need it. So you get the strength where you need it and the aesthetics where you need it. With the Argen Z GT, we have a patented smart gradient technology, which gives you micro mamelon effects in each layer, which reflects light more like natural teeth.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line Ori 3.0 intraoral scanning system without buying any inventory. Ori offers lab owners $0 down monthly pricing and a fully turnkey scanner program. Ori ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
What exactly is smart gradient technology? Stay tuned as we discover the answer together. Let us begin with a common multi-shade disc. I've seen them, you've seen them. Indeed, they are everywhere. But how are the layers arranged inside? Let us open one up and see for ourselves. Here we see where a future dental unit will be placed. But we still require those multiple layers. Let us add them now. There we go. That is quite professional. But wait, aren't those lines a bit harsh? Let us look closer. Oh dear, they are very harsh indeed. We simply cannot have that. But does this affect the final product? Behold, this is a photograph of a competitor's disc. Oh my, look right here and here. That is certainly not the Argen standard. There must be a better way. Wait, doesn't Argen have a superior plan? How can Argen possibly improve upon this? Let us observe what Argen does to these layers. Well, look at that. They have blended them to more closely mimic nature herself. Isn't that something? Now, when sintered, we achieve a marvelous natural blending of these layers. Fantastic. This structure exists within the tooth, not merely as a surface variation. The result? A natural-looking translucency, just like, well, nature. Argen ZGT is precisely what you require. It possesses marvelous strength and truly smart gradients. Let us take a final look at these layers to see what makes them so intelligent. Observe, Argen has placed the layers exactly where they are needed most. We find great translucency at the very tippy top of the teeth. Yet, just below, the material grows stronger where the connectors reside. At last, we can have everything we need. The versatility of ZGT. That is very helpful in keeping things strong indeed. But you may wonder, is this disc suitable for every indication? Let us investigate. First, let us look at a simple crown. The properties of Argen ZGT make it ideal for those aesthetic cases traditionally reserved for Argen ZSTML, 5Y zirconia, or even lithium disilicate. Now, you can simply utilize Argen ZGT and be confident that your crowns will be simply beautiful. Now, what about those tricky bridges? Bridge cases benefit from aesthetic beauty and translucency in the incisal gradient without sacrificing strength in the connectors. Argen has you covered. And what of the full arch? These too benefit from that same beauty and translucency, while the transition zone is strategically placed to allow for even the largest of arches. So, for crowns, bridges, and full arches, Argen has precisely the disc for you. And tell me, why carry such a cumbersome variety of discs in different strengths and thicknesses? Simplify your laboratory and carry only Argen ZGT. It truly is the disc you've been looking for. Argen Z, better than your mother could make. That is, unless your mother works for Argen.
Hi, I'm Charles Banh from Portland, Oregon, speaking for Argen here in a couple minutes. I will be talking about FP-Whaaaa. FP1, FP3, how to figure out what to do, what works, what doesn't work, and I will see you there.
I'm David Jackson from Nashville, Tennessee. I own Mid-South Dental.
as this is the moment you've all been waiting for. Introducing, on behalf of Stephanie Dahl and the Argen Corporation, from Portland, Oregon, the reigning, defending Asian Persuasion, Charles Banh!
Stephanie, you don't have to introduce me.
I am so lucky because I was going to try and do that.
And I didn't tell you earlier because I wanted you to be sweat a little bit. So can't beat that, right? So I know what you're thinking. I am taller than what you thought. Right? So that's always good. That's, I think, what you call under-promising, over-delivering, right? So I told Michelle, she asked for my height because they find the ratio for this. I'm about almost 5'9". I told Michelle I was 5'7", because I nothing worse than being shorter than your fake person, right? So yeah, my lab's in Portland, Oregon. We only do full arch. The challenge with this is that's live stream. So I can only give this talk once, because nothing worse than you go someplace and you show something and someone's already seen it, essentially. This is my home crew. It's my wife, Esther, my son, Dean. He's turning 4. And then my son, Connor, is 7. And we are really big hockey fans. I grew up playing hockey in LA. LA has a pretty good hockey scene. You know, when Gretzky came to the Kings, all of a sudden hockey exploded. So I grew up, we've got a lot of hockey rinks. In Oregon, we don't have as much. We don't have a pro team. We've got the Portland Winterhawks, which is our minor league team. It's the Chicago Blackhawks farm team. And we have season tickets. It's super fun. And my son Dean's really taken to it. We've got a little bit of fake ice in the garage. And he plays every single day. He wears his stuff to bed. He keeps all stuff under his bed, so it's super fun. But what I always try to do is I always try to have like a book for the year. And so last year I presented a book. This year it's this. So for the younger people, this is called a book. You know, we cut down trees, and then we take the flesh, and then we press it, we print on it. But this is a great book. It's called Unreasonable Hospitality. It is available in audio. It's a fantastic audiobook, actually. Yeah, it's a great audiobook. And it's about a restaurant called 11 Madison Park. Has anyone heard of this restaurant? Yes, yeah. So the images you saw in the beginning are from the restaurant. And when they were coming up, they were invited to the celebration where they announced the top 50 restaurants in the country. So they go there, and you don't want to be announced first, because that means of all the restaurants, you're the last, right? You're the 50th. So they get there, and they were announced as the 50th. And it was super depressing. And they were like, well, how do we become number 1? And the chef said, you know, I can't cook any better. Right? I can't be more innovative. The top 50 guys are just savants. Like, we're not on that level. So how do we get to number 1? And they thought, well, let's control the one thing that we control, which is hospitality and customer service. So it's called Unreasonable because they do ridiculous things. I'll give you a couple examples. So number 1 is that when someone books a table, they ask them if they drove to the restaurant. And if they say yes, they ask, okay, where did you park and what kind of car did you drive? And what they do is during their service, they actually will go to the meter and feed the meter so that they don't have to worry about our parking's getting run out, we have to run back and forth. Like, they do little things like that. And they do kind of a little bit bigger things. This one family was visiting New York, and they were talking about, oh, we went to all these great restaurants in New York, per se. Now we're at 11 Madison Park. The one regret we have is that we never got a traditional New York hot dog. So the server overheard that. He ran out, went to the hot dog cart, bought a hot dog, brought it back. The head chef's like, what is this? He's like, trust me, they cut it, they plate it, they bring it back, and the people just lose their minds. So hospitality does not have to be expensive, right? It requires thoughtfulness for sure. A couple takeaways from this book is that it may not be possible to do everything perfectly, but it's possible to do many things. And one of the challenges is what are the many things that we're gonna focus in on and be world class at. For us, it's full arch. We don't do anything else. We don't do crown and bridge. We don't do single units. We don't do removable. That's our jam. We focus all of our attention on it, and we fail very quickly, which is how we iterate quickly. Also, no matter what business you're in, you can be in the hospitality business, and that's our team goal this year is to be the best in hospitality. We're in this age of AI, and I think we lose a lot of human touch, right? But a lot of people are saying, hey, some lady just came up to me, handed me a card and says, hey, we can use AI to take over your incoming calls. Well, I don't necessarily want that. Not that it's a bad thing, and every lab is different, every business is different, but I actually want to inject more humanness into what we do and in the interactions that we give our customers and our patients. So one of the things and one of the focuses is 50% is the product, but 50% is the experience and the delivery, right? Because we can only get so good at this, right? Even if we're world class on this, if we fail on delivery, we're not really given the good experience. And so the real focus is, okay, well, how do we deliver an amazing experience? And so here's a couple examples is we always send photos as the case progresses. We take lab photos, we send it to our clients, and we do that for number one so they can see the progress of things, they can see the craftsmanship of it. I find that sometimes they get a final arch, they don't know necessarily what work went into that. And so we send a photo of it's milled, we do our pre-contouring, it's all done by hand with a lemon blade, we infiltrate, and then we send this photo with them, and then when it's sintered, we send them a sintered photo, like, hey, everything's sintered great, and we finish the case, and we send these photos. For number one, they can see it. Number two, they can use that on their website, in their portfolio, and then it kind of brings everything to life. So then when they finally get it, it's like, oh, this is cool. I've seen this thing being born, essentially. It's a very different experience when you set it up that way, right? And not to say this is anything special than what you do, but the way we set it up, it doesn't just show up in the mail. We create this anticipation and this experience so that when they get it, they're happy to pay for it. Real life example is our pickup delivery car is a Prius, and we put a lot of miles on our pickup delivery car, just like all of you do. And I recently took it in for service, and I get an email, about an hour later, and it's got this breakdown of, hey, here are things that need to be fixed. These are things that are good, and then here are things to kind of keep in mind for next time, which is nice. Right? It's nice to get that. When you compare this Toyota to Lexus, I recently took my Lexus, no big deal, to get serviced, and then look what you get from Lexus, which is a Toyota company, right? Same company, value product, premium product. Right? Notice the difference here.
Hello, this is Kevin, technician here, Lexus Appointment Vehicle Inspection. Under the hood here, no concerns at this time. A quick inspection of our front and brake pads. Rotate this forward. Coming up with about 8 millimeters, or actually, you know what? Closer to 10 millimeters. Yeah, those are in really, really good shape. They start out at about 11, so basically brand new still. Yeah, same on the rear, coming up with about 8 millimeters. Those start at around 9-ish. Our tire pressures were low on arrival. Normal in the winter, no concern with that. 8/32 of an inch on the tread depth. Yeah, about 8 on the side as well. Underneath the vehicle here, no concerns on the drive line. And then up under the front of the vehicle, down below here, turn our light on. No oil coming off the oil pan. Looking over at the transmission, it's looking clean and dry as well. Yeah, peel this up and actually see the front of the engine. All looking good. Just a lot of water. Okay, no concerns or recommendations for you at this time. Going to continue on with our 20,000 mile service and vehicle inspection. Thanks for choosing Lexus of Portland today. Have a good afternoon.
Is that a big difference? A huge difference, right? Does that video take a lot of time or money to make? Not at all. But you know, number one, it's a very personal experience. You really feel that they put a lot of thought and energy into the process, and it just makes you feel good. And so we took that, and then this is our spin on it, is we do kind of a farewell video for every single case that leaves the lab. I do it myself. Here's an example. Hey, how's it going? It's Charles. This is Martha's case. Everything's mounted on the articulator. You can see in the upper arch, even contacts all the way around, including the interior. On the lower, make sure you deliver the crowns first before the implants. So deliver these two premolars first, and then deliver the two implant crowns. That'll give you the easiest draw and placement. And then something we're doing this year to kind of make it a special moment for the patients is that we include a gift card on behalf of both of us. So for Martha, I'm including this note. Just says we're excited, and then there's a gift card from you and us, Montgomery Street Dental, Ceramics Dental Lab, and it's a $100 gift card to House of Prime Rib. So I'll put this in an envelope. It'll say for Martha, just remember to present her with this after you deliver the case. And then what I'll do is I will also make sure I send you some lab photos of the prosthesis. These are all going to use normal Strawman screws, 15 Newton centimeters, you know, pretty standard stuff. So thank you for sending this case to us. Looking forward to seeing it on social media, and give me a call if you have any questions. This will arrive tomorrow, Friday, and Martha is scheduled on Monday. Take care. Bye. So one of the things that I do in this video, right? Number one, what I do is I always say my name so he knows. This is an out-of-state client. I'll potentially never meet him in person. I always boast about my product. So whether we do nickel screw channel, with titanium bar, whatever thing that's special, I always boast about that. I include lots of positivity, right? A good tone, like, hey, this is gonna be really great. I'm excited for you. And I thank them for sending the case. And if you noticed, we send that gift card. And this doctor's in San Francisco. We look up like the best steakhouse. We try to verify that that patient's not a vegan, right? But we send it, and when we started doing it, number one, we do it on behalf of us and the restorative doctor. And so basically it's free marketing for them. They deliver the case, they give it to the patient, and they absolutely lose it. They get plenty of people have called me thanking me because they'll get the gift cards or thank you cards from the patients. And so we do that, and then I send it immediately to the doctor, and I always get a text back, you know, and they do appreciate it. And for me, like, that's basically, you know, almost a $9,000 case. Spend $100 on a gift card. That's basically my marketing budget, and it's money well worth it. So, right, the topic is really, right, FP-Whaaaa, FP-3, like, what are we doing and what are we looking at? This is the patient, Nala, and we always have the patients come to our lab. We take all our own photos. If they're local patients, always take a smiling photo, do shades, try to get the exaggerated smile as much as you can, and I always take a close-up photo as well. In the case, if it's going to be an FP3, right, I want to know gingival shade. I'm never going to get a good gingival shade picture from a restorative dentist. That's the prosthodontist, right? Like, but for the most part, we're not going to get that. So I try to get that myself. So I've got a really good, you know, landmark from where to start from, in case we're stacking porcelain. Just a very simple setup, right? We've got just a good lighting, some backdrops. This is our Zircon-Zahn face hunter. So the patient comes to the lab. We do our full workup, facial scan, photos, and then we sit down with them, and then we basically say, hey, like, what do you want to change about your smile, right? This patient may not have already approved treatment. They've seen the surgeon, they've seen the dentist, they might be in between, and every single time, they've never been asked, like, hey, like, what do I want to change? They get talked about implants and bone and healing in the process, but they never get someone to sit down, like, hey, like, what do you actually want to look like? And so we do that. It's a very simple thing. They're about 45-minute appointments. They're complimentary. We do not charge for them. That's also part of our like concierge service. And then we upload these patients to SmileCloud. So SmileCloud is a cloud-based software. It's AI-driven. And the idea is that it takes the photos, it creates custom tooth libraries that are unique to that patient. And then based off of that, I can actually download the STL files and use those for the workups. And so we do this in front of the patient. I take the photo, I do the workup. They're blown away by it. And about 6 months ago, they started creating video simulations. So from the 2D photo, it'll create a video simulation. Here's a patient, Jenny. This is her pre-op. The plan was to do an upper full arch FP3. And so Jenny came to the lab. We take photos, right? I do a mock-up. We show the simulation. And then now with the AI-generated video simulation, it actually will bring it to life. So from the 2D photo, it creates basically a video simulation. So this is the pre-op, and then we have a simulation of our simulated result from that custom tooth library. And this is meaningless if we can't actually execute on this, right? This is really fun and sexy, and I would say 80% of the time, the patients cry when they see this video in the lab. But this is not useful if I can't actually carry out on that plan. The difference is that if they accept it, I can take these STL files and actually take them into ExoCAD, whatever you use, and actually use that for a wax up. So here is Jenny's actual result. This is the week after surgery, extractions, implants placed. We use iCam, we scan, we deliver next day, milled PMMA. We have the patient go to the general dentist's office after lunch. We usually deliver by 10 o'clock. We charge about $1,800 for that service. So chairside iCam, milled PMA temporary. We charge per arch, direct to the MUA with DES direct to MUA screws. So this is the actual result, and this is the generated video from the actual result. So the question is, well, how close did I get to my prediction, to my hypothesis? So here's my prediction, and then here's our actual. So I would say like pretty darn close, right? It's not going to be perfect, but what I do is that we actually take the patient's wants and needs, and then we communicate it to the whole team. So I know, the surgeon knows, the dentist knows, they sign off on it, and then we execute on it. And that's the real challenge, is taking the plan and then getting it to, to the actual result. And this case is fairly straightforward. The bar for making Jenny look good was really low, right? Question, yeah. So the question was, when we do this with a patient, are we talking about vertical, different FP1 versus FP? Yeah, we talk about it. We'll go through all that. And for better or for worse, sometimes it's the first time that they're hearing some of these things. Oh. Oh. No. So the question is, well, when we order, so the smile simulation takes about a minute. So there's no ordering. I set the teeth in the software, and then it creates the simulation based off the tooth position. A lot of the facial movements are they have their own algorithms for it. So regardless if it's an FP1 or FP3, right, if they have a larger smile line, it will be more exaggerated. But the movements in the video isn't necessarily FP1 versus FP3 specific. Yes. Yeah, and so this next case will answer your question. So this is a case that I used to struggle a lot with, right? So obviously, like loss of vertical, okay? This is gonna be a double arch hybrid case. The plan was to do an FP3, and the challenge is, well, number one, how do we find out where the teeth are supposed to go? How do we find out if that's gonna be an appropriate vertical? And then how do we take that vertical from the temporary to the final? Like for me, these are the cases that were super, super challenging. We always had a lot of occlusal issues and vertical issues with a case like this. So this is Darren. He comes to the lab, I take the photos, I do the smile design, and he approves the case. And so what we do now is that in SmileCloud, we have our photos, we import our STL file, and this library I can import into 3Shape as a custom library. So the teeth are unique to Darren, right? I'm not forcing Darren into an existing exocad library. This library is unique and made for him. And so I have a zircon on. I designed this in Modifier, and I designed a snap-on smile based off the library, the tooth position that we created within SmileCloud. So this is, I think it's called mock-up in Modifier. You can do the same thing in exocad. You just set it up differently. But then we mill this out of basically an acetal. So the same thing we would use like for a flexible partial. We mill it, we send it, the GP delivers it, the adjust occlusion, and he wears that for about 4 to 6 weeks. During that time, he might come back for further adjustments. We can verify aesthetics are correct, and that he can handle physiologically the vertical that we're putting him in. So once that's approved, he comes back, and we take a new CT scan. This is the key. We take a new CT scan at that vertical with him wearing the prosthesis. And it's preferable to have a full head so I can see the condyle position, because the whole part in the game is how do I get him into a repeatable CR position? And so with the full head CT, I can look at the cross sections and verify that the condyle is seated in the fossa. And we do not use registration markers for our photogrammetry. We actually use the CT as a registration marker. So we use radio-opaque healing caps. We take a post-op CT scan. We merge the data together, so the CR is dead on every single time. We do not have any occlusal issues. You can see here the condyle. I can verify radiographically. It's seated, so we're in a repeatable CR position.
What radiographic healing buttons do you guys use, or radio-opaque?
Yeah, we make our own. We have a lot of Strawman in Portland, so we basically scanned and duplicated the Strawman 8mm healing cap and also the mushroom healing cap. The iCam healing caps are also radio-opaque, but you can use basically any one you want. We use just an X-ray resin. We design it, we print it, and then we just use the standard occlusal screws. But I like to have, my surgeons don't reduce enough tissue. So if I use a mushroom cap, sometimes there's tissue around, sometimes the tissue creeps above it. So I like to have a tall 8mm. I've had cases where I get the scan back, I can barely see the tippy top of that healing cap when I'm merging my photogrammetry data. So I like to have a taller one. Right, so another case, similar thing, right? So right there, that's the incisal edge of like 24 or 25, right? No posterior teeth, no posterior stop. If you take a look at her intraoral scan, you can see we've got almost zero restorative space on the posterior left and right side. The plan was to do a lower FP3. And so same thing, right? Not only do we have to open her vertical, but I need to give her a posterior stop. Because when I give her a temporary, I don't want her lower teeth going up into her palate. I want to maintain that vertical. So do the same process. She comes to the lab, do a face hunter, we do a smile design, we mill out just the acetal snap-on smile, and then she wears this. We verify the vertical that she can handle physiologically. We did have to do some adjustments to this, and then we take a final CT scan, right? So use a CT scan, and you'll see this. We actually did this case already, but this is her. She knows how much vertical space we gained on the posterior bilateral sides, and then you'll see in a second here with the reduction in the implant positions. These are radio-opaque Strawman 8mm healing caps here, and so we go directly off of the CT. I do not even use soft tissue scans anymore, right? So do the surgery, do my photogrammetry scan with the flap open, and then we do a post-op CT. There's no point to even do a trio scan because I am the one shaping the tissue with my temporary. So this scan here is sort of kind of a formality for us. And I'll talk about more of that later. I think this is the key for these FP1s is I actually go off of this, and I'm developing the tissue. I'm not using that post-op tissue scan on these. So going back to Nala's case, right? She shows a lot, definitely. Here's a pre-op, and then here was her simulated workup. And so now we get into the heart of today, which is, well, this is going to be a very tricky case, right? And this could be, if I showed this case in Europe, this would be an orthodontic intrusion case that would take over 2 to 4 years, right? When I show this case in Europe and I show a big bone reduction, they boo, they throw stuff at us. They think we're barbaric for doing that. So FP1 or FP3, right? FP1, I mean, very challenging. She has no posterior teeth. And FP3, well, the question, does she have the bone for us to move that transition line high enough? So her anatomy will almost dictate what we do in these cases, right? So FP1, just teeth. FP2, longer teeth, a little bit of tissue, and then we have our normal FP3, right? So then we categorize it, right? This is what we're talking about today. And if I gave you an analogy, okay, FP1 are like shorts, right? FP3 are like pants, and FP2 are like jorts. You don't plan on jorts. Jorts just happen, right? Maybe you give, hillbillies like to give second chances to jeans, and then you get jorts, right? That's what you end up with. No one plans on this. You plan on that, or you plan on that, and somewhere along the line you screw up, and then you get that. Like that's kind of where it is. And so for Nala, right? I mean, there's other criteria here that are at play, just not this. One of the things is, right, looking at tissue and biotype, right? So if you look at the literature looking at gingival recession in relationship to periodontal biotypes, right? We're just looking at thin versus thick biotype. Obviously, I'm not going to probe the patient, but if you look at Nala, you can see she's got thick tissue. You can't really see the tooth eminence clearly through the tissue. Look at the shape of the teeth, right? Thin biotype, longer papilla, more triangular teeth, thicker biotype, right? More sort of rectangular teeth. So it's very easy to kind of look and know pretty quickly, hey, like just off of tissue, like we might have an issue here. Also, this is classic Dennis Tarnow from 20 years ago, looking at implant to implant tooth relationship in regards to contact point and papilla regeneration. And what happens is that we know that natural teeth have different support than implants do. So as we extract a tooth, place an implant, that support follows. As that bone decreases, the tissue falls as well. And the average of a lot of these cases was about 3.4 millimeters. And so on these cases, right, thin biotype, implants closer together, like those things also influence what happens to the papilla. And as a lab, like there's very little we can do about that. We can design the perfect temporary, perfect ovate pontics, but the biology plays a big factor in this as well. And unfortunately, like the reality is a lot of these dentists that do these cases, they do FP1s because number one, either they're afraid of doing a bone reduction, or number two, they're sort of planning for the future, right? Nala's obviously a young patient. What will happen in 30 years? So they expect failure of an FP1, which turns into an FP3. So the backup is an FP3. And then as that fails, the backup is a quasi-goma. So they're building in sort of redundancy into the system. Not to say that's right or wrong, but we're also kind of forcing people into something that's not the best for them, right? If we give Nala a very poor result, she's not going to care that in 30 years she's got a plan B. So thick biotype. The challenge with her is she has very pneumatized sinuses here. So these posterior teeth have been gone for a long time. And so we've got no teeth in the back. We've got a very low sinus. And so that means when we design these cases, right, for an FP1, we got to have a lot of implants. This is not an all-on-4 with an implant, 30 degree, 30 degree. We've got a pretty good spread. We would definitely want to have a terminal implant. This is not Nala's case, but this is the average kind of workup that we're looking for an FP1. We also really need to have as many teeth as possible because we're utilizing the existing emergence profile and papilla architecture. If there's no tooth there, we're not getting the papilla back. That's going to be a ridge lap tooth for us to make it look good. That's not going to be an ovate pontic situation. And so if you look at the implant position, right, we have our ovate pontic, we have our MUA, and so there's a certain amount of space that we have here. So this is not going to be an FP3 because as her sinus comes down, we can't reduce high enough to make this be an FP3. So this is one of the cases where we have to decide, okay, and be honest with the patient, hey, this could be your result, where we just replaced the teeth, and this, thankfully her papilla is already pretty blunted. She's a diastema here already, but she's ended up with long rectangular teeth. She will end up with chiclet teeth, realistically, right? And she may not want that. And so this is a case that's still sort of pending, because if we do an FP1, we need a sinus lift, we need a sinus lift here. This is going to be, 6, 12, this is going to be an 18-month case. So that's the challenge with it. What about scalloping? What about scalloping, right? Do we need to scalp? And we did these guides for a long time, where we planned, hey, like we need to have space, we need to scallop the tissue. We would make these, this is in co-diagnostics, we would design these guides where it was sort of a stackable guide. This would be on the tissue, this would kind of go on top, and then whatever came through would have to be reduced, essentially. And then we had another temporary that's stacked on top so that we can verify. I don't prefabricate temporaries for these cases. I think photogrammetry is superior to them. The timing, though, is a little bit challenging. And so what we found is that we would do these cases, we'd do scalloping, and then we'd scalp the bone. In 6 to 12 months, the body would naturally scallop itself more than that. And so what would happen is we would get additional bone loss, the tissue follows the bone, and then all of a sudden we've got a lot of these spaces that aren't going to be conducive to ovipontics. So we were overdoing it, because what happens is that the literature shows even if we have 2 millimeters of buccal bone, we're going to lose bone, right? Here's the temporary, right? Looking at survival rate of immediate implants and looking at tissue loss, it's very variable from patient to patient. And it could be a millimeter, it could be a millimeter and a half. We don't really know, but what will happen is even in a ridge like this, we will have bone migrating this way, and we will have bone migrating that way, even if we do 0 scalloping. So why accelerate what the body's going to do naturally? And so what happens is you do this because you think you're supposed to do it, you create a bigger ovipontic, and then over that year, right, the patient's in the temporary for maybe 3 months, you go to final, and then 8 months later they come back looking like this, right? Because their biology has taken over, and that's not something as we as lab techs are really supposed to or trained to look at. But the takeaway is, hey, there's going to be more recession and bone loss than we can anticipate, and the scalloping kind of creates even more than that. Here's a case. This was on a Parkinson's patient. It was a patient where all of our appointments were done under IV sedation. And so they placed implants. I can't remember how many teeth they had, but we did a temporary, went to a final. This is August of last year, right? Look at, this is the tissue. Here's the design of the bridge. And then we did a bar on this case. Dentist calls me last month and says, hey, Mike's lost a lot of tissue under his prosthesis. So I'm like, okay, scan it, send it to him, let me take a look. Right, this is January of this year. Right, look at how much tissue he's lost, right? And if I bring it to exocad, I overlay it and look and quantify that tissue recession change, it's a lot. Almost 2.5 millimeters facially. That's not something that we take into account, do we, when we do these cases? But is he an outlier? Like maybe or maybe not. But there is definitely going to be changes that happen. So one of the questions is, okay, well, how stable is this tissue over the next year, 2 years, 3 years? There's not a lot of data specifically looking at tissue stability in FP1 fixed prosthetics. That data does not exist yet. There's a couple that we can kind of infer some things from. This is maxillary cases over the follow-up of 1 to 12 years of full arch fixed. And soft tissue recession, they just have presence or absence, right? But probing depth, you look at the breakdown, right? Greater than 5 millimeters, 4%. 3 to 5 millimeters is basically 28% of these maxillary cases over 1 to 12 years. We'll see, right? 30% of them will see 3 to 5 millimeters of bone change that we have no idea is going to happen. And so there's a lot of question marks on this, and that's something we have to tell the patient and tell the doctor, right? This might look amazing at 12 months. This might look terrible at 18 months. That could happen. We don't really know. That is why, like DSO type flourish practices, FP3, predictable, right? FP1 is so biology based, and we don't have good data surrounding it. So, the question was, is there data in Europe about FP1's like soft tissue predictability? Not specifically to FP1. They do a lot more of them. They do a lot more FP1. There isn't a meta-analysis. There's not. What we need is a 10-year meta-analysis. Hey, of all these FP1s, let's look at the mean soft tissue. We don't have that. Doesn't exist. Yeah.
After a year or so, is there something you can have any literature about that?
So the comment was, we see a lot more FP1 in the U.S. and we don't have literature. And I mean, I agree. And there really isn't any right now. Yeah.
So I noticed there wasn't any partial traction therapy.
Yeah.
On the FP1, do you have that?
Like socket shield, like root banking. Yeah. Yeah, I would say I agree. And the people I work with in Portland, that's such a minority. I would love for people to do that, but yeah. Yeah, no glaze, polished zirconia. Yep, yep. Yeah. No glaze. Yep. 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 For sure. Yep. Yep.
That's a tight connection to the implant, but the prosthesis to the multi-unit is not zero bone. I don't know if you follow the zero bone loss concept.
Yeah, like Avincius, yeah. Yeah. Agreed. Yeah. Yeah. Yeah, for sure. Yeah, I agree. So a couple of just basic, based off of my, anecdotal meta-analysis of the literature, right? Like this is kind of where we start to see, in most cases, like some type of stability happen. But again, there's so many outliers in this process. And then when we go to final, it's challenging for me because I've always preached like, hey, like I don't like using zirconia direct to multi-unit because of the variability in screws, because of the variability in like milling screw seats for them. So I've always been like, hey, let's do a bar zirconia sleeve. The problem is for a lot of these cases, right, like this type of design is not the best, which is more of like a veneer type of design done in Blender, right? We do a night guard for these, and then this is the case delivered. But the challenge is that like this is not, like the way this looks now is not how it may look in however X amount of time. But the real challenge, I think, is this. We always do next day delivery for our PMMAs off photogrammetry. But the problem is we need to push the tissue, right? So if this is going to be if this is going to be an FP1 scan, these are like just the mushroom healing caps. This is not very useful. And so if I create ovate pontics the way I'm supposed to, and the patient goes to see the dentist the next day, that's going to be a tough appointment. Because you're basically pushing into an open wound, right? And so we've altered our protocol for these a little bit. For these cases, we will do a print and deliver, but before the patient wakes up, because we want to be able to push the tissue and deliver it before they come out of anesthesia. So this is a little bit different of a routine for us, but we would take the scan, whether it's opti-splint or photogrammetry, with the flap open flap, so that we can see the architecture of the bone, and then we design a prosthesis, we print it. We usually, if we take the scan with the flap open, by the time they've done suturing, bone grafting, and the patient's kind of slowly maybe coming out, it's been an hour and the prosthesis is done. We can jam it in, deliver it before they can feel the effects of pushing that tissue. And so that's our change to the protocol. It's going more off of the bone architecture than off the soft tissue. But just looking at some takeaways from Tarnow, right? Especially critical in thin biotype. And so FP1's done on thin biotype cases, very, very challenging. And then, of course, like you mentioned, the zero bone loss concept, right, is very much dependent also on tissue biotype as well and biologic width. So those are some challenges. So what we do is, this is kind of our parameters for this, or at least from the literature. The problem is these parameters are not applicable for us and for a surgical temporary, because there's no blanching, right? It's a wound with sutures. And so we got to go off of the bone. So we do all of our scans with an open flap. We design according to the architecture of the bone. We do a same-day print instead of a next-day delivery, so that the patient, we can create ove pontics, they're not uncomfortable. We do a scan, body scan, the flap open. I know my printed temporary is going to break, right? I verbalize that as an expectation, so I mill a PMMA backup that's delivered 2 days later. So when that printed provisional breaks, they've got something good to deliver, nice polished PMMA. And then I like to keep them in the temporary for more than 6 months. Bach leaves a surgeon in Los Angeles. He keeps his patients in temporary for a year. And so I changed my protocol. We still charge the same way for a temp. We charge $1,800 for a temp. And then instead of $6,000 for a final, we charge $7,000 for an FP1, because I know that I will be creating at least 2 to 3 temporaries along that process. And I don't want to nickel and dime. I don't itemize. I have a one flat fee. They charge the patient. I feel better because I'm not eating the cost of these temporaries. And we just tell them, hey, you know what? Things are going to change. Expect to be in this for a year. And that I don't have enough data to tell you if that's made a big difference, but that's what we're going to try to do. We can make it, yeah, and we've been doing that too. Yeah, zirconia temporaries as well. Super easy. Polished zirconia, one big glaze, not a big deal. Yeah, super, yeah, I agree. So going back to this, I don't do this anymore. The problem is, this is more like an L-shaped type of sleeve. It's not encompassing the bar. And so when I do these, not often, but I will get fracture. And a lot of it is I think, through protrusive. Right? And it's not zirconia fracture due to occlusal forces. It's when they slide through protrusive, we're getting fracture and delamination. Because this, right, it's kind of an L shape. This zirconia is not like a taco going around the bar. So, you see a lot of this because it's sexy and easy to do in Blender to do. Some people will also say it's good to keep the cementation line away from the tissue, which is why I did this. I figured, okay, polished titanium, better than having a micro gap right at the tissue. But then you get this occasionally, especially in FP1's limited restorative space, right? Delamination or fracture upon going through protrusive. So I've been okay doing a lot more of these, which is direct MUA for our finals. And I use this screw, which is the DES 19.069, which is what Argen carries now, because it's compatible with the Strawman driver, do a lot of Strawman, and it has ASC capability built into it. You do need to buy them a lot at a time because they go back order weekly, and it's incredibly frustrating, as you probably have already felt. I only carry 25 millimeter pucks in my lab because 90% of my cases are FP3s, right? My FP1s can fit in 18s, but I just don't carry them because I don't do enough of them. So it makes sense for me to actually send this to Argen to do, because number one, my zircon Zahn is a closed architecture cam, but if you've got hyperdent or a mill box, you need a special burr, right, to go in and mill the screw seats. If you don't do it often, it can be challenging to know, like, hey, is this a passive fitting screw? Are you doing it modelless sometimes if it's a photogrammetry case? So these cases, it makes sense to send because I don't have to keep the puck in inventory. They're milling it HE high definition, and it's going to fit. So these are cases where it makes sense to send to Argen. You guys have these screws now, right? They're in stock. Yeah, so I'm going to buy a bunch. Oh, not in stock yet. They're coming. Okay. Got it. Yeah. Yeah.
So you said that you use Strawman. What about on the straight MUAs, that annealing screw channel is, the annealing screw is just a touch shorter than the Strawmans, and I find that it just barely engages on the straights. It's great on 17
Because the Strawman MUA is slightly shorter than the traditional MUA.
Because when the SCS driver goes in the top, unlike the Nobel FP-Whaaaa and the FP multi-unit driver that goes over the top, that they have to accommodate room for the SCS, and then so they start their threads down lower in that straight.
Yeah. So, yes.
Especially the Strawman Zygos are made by Southern.
Yes.
They're even just
A touch. The threads. Yeah.
and those don't quite engage. Those won't engage the Zygos.
So I think there's a library issue there, because they have a specific library for the 19.069 for the SRA. That's the difference, because all the other MUAs have a Nobel type of geometry, right? The SRA is a little bit deeper. The screw seat's a little bit deeper. So if you use your traditional Nobel type library on an SRA, what happens is there's a space above the SRA from where the prosthesis sits. So you need to use a specific DES 19.069 library for the Strawman SRA, which is on the website. Yeah. Okay, so going back to this, right, contraindications, it's easier to tell you what are the contraindications for FP1, because the obviously backup is going to be FP3. So for me, like excessive gingival display, and then specifically without the necessary room to move the transition line above the smile line. That's a big one. This is one that we as a lab can definitely manage with photos, proper photos, CT scans, and then we also take videos, right? Take a video, make a poop joke, see them smile big, right? That Duchenne smile on a video is much better than what you'll ever get on a photo. So we do smiles for these. Thin biotype is going to be very, very challenging. Missing maxillary teeth is a big one, because again, you don't have that natural architecture of the emergence profile to build into, so those teeth are going to have ridge laps, modified ridge laps. That's the only way you're going to make it look good. Pneumatized sinuses, meaning you can't get that posterior implant back far enough. Like these are most of the reasons why we can't do, at least in my patients, we can't do FP1s for these. So look at this patient here. This kind of summarizes what we talked about, Sarah, right? Like she's got all the things, right? Thin biotype, you can see the tooth eminence here through the tissue, long triangular teeth, so thin, classic kind of thin biotype look. No posterior teeth here. And then to make matters worse, look at the CT scan, right? We're not getting implants back here. So this is the classic case. She hits all the contraindications for an FP1. But she comes to the lab, we do a workup. So here's her pre-op, and this is kind of what we did. And then we do our video, right? That's her pre-op video. And then here's with her smile design. And then she says, well, like, how are we going to do this? I mean, honestly, the only way we can do this is with an overdenture, right? I mean, that's kind of throwing this into the mix. It's not an FP1, it's not an FP3, but a lot of these cases really should be bar overdentures or some sort of telescopic type of prosthesis. And I don't like doing these direct to locator. I mean, in the literature, there's a lot of failures off of these type of overdentures, directed locators, especially in the posterior maxilla, like softer bone, right? Patients who will put a lot of pressure and torque on these. So I try not to I don't like to do these. And I also hate acrylic. So we get these, right? I mean, like, what are you gonna do with this? All the time we get these cases, and they just weren't designed properly. This case was actually pretty nice. It had upper and lower Panthera double bar MK1s, but still, I mean, like this, like someone paid a lot of money for this. They don't expect to be in this situation. So I don't like to do acrylic. I don't think acrylic is really a long-term material. And there's some pretty good literature, right? This is from Jomi in 2020, and they actually looked at financially comparing zirconia versus acrylic fixed hybrids, and they looked at 74 cases, and what they found was that the mean follow-up was 8.7 years, which is not that long, because we expect this to last 30 years. So the follow-up is actually not that long. But look at zirconia survival rate, about 94%, right, plus or minus 5. And then acrylic fixed FP3, acrylic wrapped titanium bar FP3s, Survival rate only 83% with plus or minus of 10. This is after only 8 years. After 30 years, this number, I assume, is going to be way down, right? All of us usually see, right, denture teeth fracturing, retreading these cases. Like, we know that that's going to have to happen. This article looks at the financial difference between the two. And what they found is that the dentist charges the patient about this much more for a zirconia prosthesis than an acrylic hybrid titanium wrap bar prosthesis. And the maintenance of the acrylic outweighed the cost of the zirconia. So if they had just gotten zirconia in the first place, they actually would have paid less, take into account the maintenance and like repair of that prosthesis over time. So that's why I don't do any more acrylic wrapped hybrids. Again, there's a lot of discussions about, oh, well, we need things to be softer and more forgiving against materials. But that's the reason why I do it, because the patient's paying $30,000, and I don't think they should break a denture tooth in a week and then have to deal with that. Yeah. Yeah.
And to me, like, I work with a prosthodontist, and he'll do like a hybrid on the lower end, a zirconia on the upper, and tell the patient in 5 or 6 years we're going to take this off, we're going to keep the metal and strip off the
yeah.
and redo the and to me that's not a failure, that's
Mm-hmm.
expected wear of that prosthesis.
Yeah, that's fair. So the comment was, consent and communication to the patient, like, hey, this is going to happen, expect that to happen, and then. But we're doing it for a reason. I think the clacking, I mean, the clacking I feel like is anecdotal. Maybe it's more of a freeway space thing. It's patient to patient. Is it males versus females? Is it the husband with the hybrid and the wife cares, husband doesn't care? I mean, I feel like it's anecdotal. It's not in the literature. Everyone's got a different stance on it. But yeah, you're right. I mean, definitely, it's all about communication. Whether you Yeah, so what I would do instead is I would do injected composite, if I have to. So I do upper zirconia with stacked porcelain. The lower I do a thimble bar. I inject or inject composite, and it looks really nice. It wears nice. It lasts a long time. You're not going to fracture of denture teeth. The composite doesn't look great after a couple years. It does become a little ratty, but it functions much better to me than acrylics. That's my. Who does that? I mean, in terms of like. So Annexdent and GC sells injectable composite flasks that are clear. You do a prototype. You make a glass matrix putty. You take it out. You put it in your thimble bar. You inject composite. Put in light cure, and then you stack. It's super easy. Yeah.
Stack Annexdent composite. So you build the frame. I do a lot of thimble bars with zirconia crowns. Then once you cement the crown, then you build Annexdent around.
Yeah.
And it takes care of a lot of that clicking noise. It's not as pronounced as it's solid zirconia.
Yeah, definitely. A good question. Okay, so going back to this, I've been trying for a long time because I know that some of these cases need to be overdentures, and because I don't like doing acrylic, I'm like, gosh, like I would love to do zirconia overdentures, right? So I'm like, okay, well, I never want to waste a puck to try it. My buddy Max and I did a talk on Thursday where we talked about capital equipment, and I have an M-series mill. Joe, you're there. And it died on us after about 3 years, and I was so angry I wanted to basically blow it up. So we took it to a junkyard and then got ready to smash it. And so this is my buddy Max, and we're at a junkyard in Oregon.
Put your helmet on. But I can't get it.
Okay. He brought his hockey helmet.
I never opened up the inside.
The shrapnel was going to hit him. So I never opened up my mill in 3 years. I've not opened up the mill in 3 years. It was taped up. I was like, oh, I should probably open it to see, make sure there's nothing inside. This is like, I could not make this up. There's the excavator right there. There's a puck in the mill. It's been in there for 3 years.
It's so. Is this what your lab looks like? It's so dirty.
No, dude. Max is trying to roast me on my lab.
Oh, seriously?
There's a
Is that
puck
pretty
in the
HD?
mill.
Let me see. There, we should send this video to Ross.
Yeah! It's an Argen 30
You have the
millimeter
tool, Charles?
HD.
That's like $300 right there.
Yeah, I paid left $300 sitting in my mill for 3 years. Yeah, I mean, you can't make that up.
So, Ross Griffin.
Ross, well, of course, Ross is in here.
Ross is my friend.
Yeah.
I got all that on video, Charles.
Can we break that?
Whoa.
Dude.
That's
It's
a
in-
donation to Crown Creation.
It's in pristine, perfect shape.
This
So
is money.
Yeah, that's true. That's over. Why is it so small?
What are you talking about?
it's a 30 minutes fat.
30.
Oh, okay.
It's a big boy.
It's a big boy.
Oh.
So I was like, okay, you know what? Like, I'm gonna mill a denture out of zirconia and like just have some fun with it. So I mill it out, and I'm like, okay, well, what's the worst case scenario? Is I mill it, and the patient drops it, like in the bathroom, right, on the tile and the ceiling. Like, what happens? So you know, like, I'm gonna test it. So my parents, they have a house in Oregon. They live in LA. They go back and forth. Right now, their house is empty because they're in California, where it's nice. So we go to my parents' house because it's clean. My kids are messy, and I'm gonna test my zirconia denture milled on my Argen 30 millimeter puck. Oh, by the way, for the younger kids, there used to be a channel called MTV, and there was a great show called Jackass, hosted by Johnny Knoxville. So this is a Jackass style segment.
I'm Banh, and this is Old Man Denture. Okay, you ready?
Mm-hmm.
Now, we should go to the floor side. Do you see the...
There's a banana.
Yeah, I see the banana.
Classic
Back up
banana
here,
on the
okay.
bathroom, right?
Oh, okay, I just woke up from bed. I'm old. Time to go clean my dentures in my bathroom. Do 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 do. Ah! I'm hurt. I've fallen. I can't get up. Just kidding. I'm fine.
Yo, dog, are you okay, old man over there?
Okay, let's see. Okay, so bathroom test 1, passed. No fractures or anything. Looking good. On to the next one. Okay, here we go. Test number 2, the sink test. Here we go. Okay, oh, I'm just cleaning my denture, Oh no, ah! Did not break. Oh no, oh no, no.
Oh wow,
Oh,
that's
no.
old man. Are your dentures
I'm
okay?
fine. They are just fine.
Okay.
Okay.
Okay, test 2 passed.
Okay.
Test 2 pass. Okay, so bathroom test. I mean, I was pretty aggressive with that thing, right? Okay, and it's not like incredibly thick, like 2 millimeter, buccal flange, like no big deal. So let's do something more extreme. I'm gonna break this thing. Okay, what does it take?
I'm Charles Bond, and this is hockey puck to the denture. Let's go. Okay.
I have not touched a hockey stick in 15 years. This took a long time. We were there for a long time. Oh, God.
Not so close, Dad.
Oh, we were there for like 3 hours.
Yeah!
Wait, what?
Got it.
Yes.
Still got the celly though.
Woo!
Still got the celly.
Woo! My dad did a good job. That was a cool video, guys. My dad did a good job. Go!
You see it? You see it? Connor, you see this?
Wait, come closer. Woohoo!
So what have we learned? If you're in a bathroom and you drop the denture, probably fine. If you slip on a banana peel, probably fine. If someone shoots a puck directly at your teeth at about 80 miles an hour, probably gonna break.
Okay, that's science. Can't argue with that. So yeah, thank you. So I started doing these purely anecdotal. I have no data on this. If you do it, that's on your own discretion. But we do like an MK1-ish style by double bar overdenture sleeve. We use the normal housings and then Argen, zirconia, cemented. So this is it. So I'm happy to announce here in 2026 Lab Day Chicago the newest line for Argen. Argen puck protection since 2026. So thank you. That's my time. You've been great. I do have a free newsletter called the 5-Minute Full Arch. It's free. We launch it every couple of weeks, and it's just mistakes that we've done, literature review. They're quick 5-minute things every Monday. Open 2 questions.
Yes.
What program are you using? ExoCAD, 3Shape, or another to align the pre-op and post-op CTs?
I use Co-Diagnostics because a lot of the times I'm already like doing, even if I don't do a guide, I'm doing a workup at least. So I do it there. And the way the Co-Diagnostics works is that you'll use a click fee for your initial, and then when you bring in the post-op, you don't have to spend a click fee on that. But you can do it anything. It doesn't matter, like Blue Sky Bio, Real Guide, Exo Guide, it all works. Anything that you can export an STL file from a DICOM, it just works fine.
How did you get your surgeons to be okay with the post-surgery CT scan?
How did I get them okay doing it?
I've had pushback.
Pushback.
The surgeons they're like, well, my patient's sedated, I don't.
Yeah, the challenge for that, the pushback wasn't really, I haven't had much pushback actually, just anecdotally in my territory. And the drawback to doing the post-op CT scan is that you can't start anything until they are, the scan. So sometimes it's 30 minutes, sometimes it's an hour if they're in recovery. So that's the thing, that's why we need to do it next day delivery. Mm-hmm. But I feel like the pros of doing that outweigh the cons. And I tell them, hey, you know those 30 to 35 minutes you spend in the beginning of the procedure placing your fiducial markers and taking a pre-op scan, don't have to do that. Like, oh, that's a selling, yeah.
Right.
Yeah, alignment's better, unlimited registration points. The occlusion is spot on. Yeah. How do you get away with it without a fiducial marker? It's a long answer. I can tell you after. But basically, because the healing caps are radio opaque, right? We use photogrammetry data. We merge the CT data sets together. So I've got my data set in CR. I take my post-op, I merge it to that pre-op using all the bony anatomy, and then I merge my photogrammetry data to the radio opaque healing caps.
So all the bone anatomy are
Yeah.
markers, so it's like having thousands of fiducial markers.
Mm-hmm.
It's so much more accurate
Yeah.
than 2 screws in the palate.
Mm-hmm. Yep. Cool.
Way better.
Any questions from the chats? No?
I think overall, doesn't it seem like we're going to zirconia too quickly? I know you were saying to get to zirconia, but I think for FP1 and FP3, it seems like FP2 should be like a 2-year healing period, and FP3 1 year at least.
Yeah, I think in general it would just be better. You just get paid later, right? But I think like clinically, you guys, is there pressure to finish something sooner?
I would argue, like, so with the length of vicious slide, so,
Yeah.
one of the zero bone loss concepts is the best material against the tissue for hemidesmosomal attachment, which creates health and crestal bone stability and not bone loss, is mirror finish zirconia.
Yep.
So the sooner, like we sometimes will mill a zirconia healing abutment, custom healing abutment, or socket sealing abutment, because it's better to have the zirconia for the overall health. So I would argue, you're trying to make the argument that it's more conservative to wait a year or two, and I could make the argument that it's actually more conservative to put zirconia on in 6 weeks, or zirconia cap.
I think I've done a couple like FP-Whaaaa zirconia attempts for patients who come from out of state. Like you just can't risk a fracture, right? And it's awesome. I love doing it. And you're right, like the cost of, it's really not that much difference, right? But I would say what has happened a lot is that the patients don't come back, which may not be a big deal if you're getting paid, right? Because you don't, certainly, but I don't know. I mean, figure that out, yeah.
And I'll tell you that the zirconia prices have been going down.
Yeah.
The printed materials have been going up.
Yes.
And so if you're doing 2 or 3 printed, like the zirconia is way cheaper.
Right. I mean, like an Argen, 25 millimeter versus PMMA, and I mean, it's pretty close, really. Yeah.
What do you think about putting zirconia, like even if it's a temporary, on a new placed implant, because zirconia has no shock absorption. So does that harm also integration?
So the question was like, if we do zirconia on like freshly placed implants, and there's no give to that, does that affect like long-term implant survival? I mean, I don't think so. I don't have that data off the top of my head.
I mean, that's, you know, like say you're doing a 3-unit bridge, you can mill it out of occlusion. You know, if you're doing an arch, you can't be out of occlusion. So maybe that's a consideration.
Yeah, I'm talking about for full arches, not for 3-unit bridge.
I mean, but you're on a soft diet anyway. I mean, I don't know.
In solid bone, after 5 or 6 weeks, you should be good. You know, maybe not zirconia the first week, but like Nuclear does, like next day zirconia final.
Yeah.
You know, so it's being done, and yeah, I don't
There was
think zirconia inclusion is going to automatically give.
We do have a quick
question from chat,
the chat. Charles, what are your thoughts on implant patients taking medications that can present issues with tissue and bone?
Oh, well, I left my DDS degree at home, so that's not really me. But I mean, you guys, medication regarding to like, yeah, I mean.
You know, IV bisphosphonates are the most worrisome. The oral bisphosphonates are typically not a problem. I mean, 2 pack a day smokers are concerning. I mean, to me, the biggest concern is pathologic rupture. You know, those patients are worse than all the medical conditions, I think. I mean, but you know, long-standing alcoholics, you know, have cracked the bone. You know, but yeah, I'm most afraid of
So yeah, so the answer to the question.
Smokers and bruxers.
Yeah, smokers, bruxers, IV bisphosphonates. Yeah, the standard.
Yeah.
Yeah. Okay.
Anybody else? Any other questions?
I have one more thing to show. This was not planned, but I will just bring this up here real quick. Give me one sec. Here we go. So I had, this is so funny. I had planned to, let's see, let me mirror my screen here. Choose content. So I sent Lance Bass a cameo request to thank Stephanie and Michelle and Argen, and he sent me this last night, pronounced Argen or Argen. So he didn't finish it, but you know what? Props to Lance Bass, because Bruce Buffer didn't ask me, he said it wrong. So when this is done, I will send this to you, and you'll have a personal message from Lance Bass. Thank you. But thank you. Have a great trip. Safe travels.
Lab owners, have you wanted to compete with a scanner program, but the upfront costs and risks kept stopping you? Here's the move. Give your clients a top-of-the-line Ori 3.0 intraoral scanning system without buying any inventory. Ori offers lab owners $0 down monthly pricing and a fully turnkey scanner program. Ori ships the systems direct, trains the team, and handles support. They'll even help you promote your program so you can attract new customers and generate more revenue. Book your demo today.
What exactly is smart gradient technology? Stay tuned as we discover the answer together. Let us begin with a common multi-shade disc. I've seen them, you've seen them. Indeed, they are everywhere. But how are the layers arranged inside? Let us open one up and see for ourselves. Here